Good morning, everyone. Thank you so much for joining. We are going to wait just a couple of minutes as people start to join the webinar to give people time to get on board. So we will be starting in 2-3 minutes. Thank you for your patience. Okay, I see that we have both our guests here today. So we will begin our webinar. Thank you so much, everyone, for joining us today. My name is Marie Whalen. I'm the Associate Director of Admissions and Recruitment for International Students. And I'm here today with my colleague, Trina Allen, who is the Assistant Director of International Admissions and Recruitment. We are very pleased to be able to introduce our professor in the Physics and Engineering Department, Professor Kamesh Sankaran, and also one of our international alumni of Whitworth, Ishan Gowley, who is the Guidance, Navigation, and Controls Engineer at Boeing in Seattle. So thank you again for joining us from all over the world. Today we are having a conversation and presentation on engineering and physics and what that looks like at Whitworth, as well as what the career options are for you as a prospective student if you are thinking about going into this as a career field. So I am going to turn it over to Professor Sankaran right now, and he will get us started.
Thank you, Marie. It's my pleasure to talk about the programs that we offer here. And what I'd like to do is have a little presentation on the background, not for the sake of the presentation itself, just so that you don't get tired of seeing my face, just have something in the background to keep us going. So the idea of this presentation is to give you a framework for what are the options we have here in the department, and we can use the content of the presentation as a talking point when we get to the Q&A session. So as Murray introduced me, I'm a professor and chair of the Engineering and Physics Department. And one of the important things to note about our program is that we are intentionally a Department of Engineering and Physics. And the reason is that a lot of the emerging technologies in engineering rely closely on advanced developments in physics, like optics and semiconductors. And so it's important to preparing engineers for future technologies, not the technologies of the previous generation, but the technologies that your generation is going to develop need a stronger background in physics than was the case in engineering in the last generation or so. So that's why we are in Department of Engineering and Physics. Let me first talk a little bit about the programs that we offer in the engineering side. So we have our in-house BS Engineering degree. The BS Engineering is an ABET accredited interdisciplinary degree. So ABET has the Engineering Accreditation Commission that evaluates engineering programs all over the world, and ABET's accreditation says something about the rigor of the program that we have developed here. And this is an interdisciplinary engineering degree. Many of you may be familiar with BS in fill in the blank engineering, mechanical engineering, electrical engineering, chemical engineering, and so forth. This is not that. This is just BS in engineering. Because it's an interdisciplinary engineering degree, it combines some foundational aspects of mechanical engineering, electrical engineering, and some computer science with the backbone of the design process in engineering. As I was saying a few minutes ago, when we think about the emerging technologies in engineering, so for instance, many years ago, when I was a freshman in college, people would talk about cars as mechanical engineering. We can all have a good laugh at that now, because when you look at a Tesla, sure, it has some mechanical engineering, but it's way more than mechanical engineering. And Ishan can share about it when he gets to talk. When I was a freshman as an aerospace engineer, it was a shock to me that 60% of the cost of an airplane was in the electrical engineering side. And here I was thinking, why am I studying aerospace engineering? Because most technologies have a blend of the mechanical and the electrical components. And now when we think about how embedded systems work in integrating semiconductor chips and computer science into all aspects of engineering, we felt the need for an interdisciplinary engineering degree. So this is a 4-year program. You'll get the BS in engineering directly from Whitworth, and this will prepare our graduates for these emerging technologies. The other option that we offer is also a very important option. It's a different one for the specialized engineering degrees. So electrical engineering, mechanical engineering, chemical engineering, and so forth. We don't offer that degree directly from Whitworth, but we have a partnership with some elite institutions around the United States. So this is a 5-year program in which you'll get 2 degrees. So for 3 years, you'll study the foundations of engineering, some of the basics that we talked about, including other math and science at Whitworth. And then you will transfer to our partner institutions with whom we have a contractual partnership agreement: Columbia University in New York, an Ivy League school; Washington University in St. Louis, an elite institution typically ranked in the top 15 institutions in the United States, and closer to home to where we are in Washington State University. And then you'll spend 2 years in this institution where you'll be studying specific subset of engineering, say electrical engineering or mechanical engineering, and so forth. And what will happen is that all the courses that you take at Whitworth will transfer over to the other institutions, and the courses you take at the other institution will transfer back to Whitworth. So you'll end up getting 2 degrees, one from Whitworth and one from the other institution. And some of the institutions, like Washington University in St. Louis, they also offer a +1 option to extend that to a master's. So in 6 years, you'll get 2 bachelor's and a master's degree. So that option is a very valuable option for a lot of our students, because when you look at the reputation of these universities, these are some of the most elite universities in the world. And we have this guaranteed contractual agreement with them, namely that if you take the specified foundational courses in math and physics and computer science and engineering at Whitworth, and if you maintain a 3.25 GPA, then those grades, those courses transfer over to the other institution. And likewise, the courses that you take at Columbia or Washington University in St. Louis will transfer back to Whitworth. And this is going to be very helpful for students who know for a fact they want to do a specific subset of engineering. And for instance, Washington University, their mechanical and aerospace engineering department has an outstanding aerospace engineering options that we don't have at Whitworth. And so for those that want those specific engineering specialties, this partnership program is an excellent option. Now, that's on the engineering side of the program. Let me switch to talking about the physics side of the program. On the physics side, we offer two pathways. We offer a Bachelor of Science degree in physics. And the Bachelor of Science degree is a very successful degree in that it prepares our graduates for a variety of careers in physics and applied physics and optics, including in engineering. And what this does, let me just get you back over here. Sorry about that automatic presentation. What this does is that it prepares our graduates to go into many types of programs. Just a fun fact, in my years teaching at Whitworth, the graduates of the BS in Physics major have gone on to 8 different types of engineering careers. So it turns out that the BS Physics is also a really good preparation for careers in engineering. And this program is also very well tailored to prepare students for graduate programs. So our BS in Physics graduates, they've gone on to, 2 of them have gone on to receive PhDs from Princeton. One of them has gone in engineering, mind you, in aerospace engineering. One has gone to get a PhD in engineering from Carnegie Mellon, from electrical engineering. Others have gone on to masters. 3 have gone on to graduate programs at Johns Hopkins. One has gone on to get his PhD in chemical engineering from Notre Dame, in addition to others who have gone on to get physics PhDs as well. So when we think about the BS Physics, think about it as a rigorous prerequisite for elite graduate programs. And in addition to graduate programs and research opportunities in physics, I want you to remember that BS in Physics can also be a really good pathway for careers in engineering as well. And in addition to BS in Physics, we also offer a Bachelor of Science in Biophysics. Biophysics is the program that brings the methodology of how you study physics and the tools of physics to biological topics. And the biophysics program, incidentally, is a really good preparation for medical schools in the United States, as well as various graduate programs in biomedical engineering and biomechanics and so forth. We have had alumni of this program go on do a PhD at Harvard in biophysics. One went to get a PhD at Caltech, and another one did a master's at Stanford and now is in the medical school at Stanford, graduating from this program. So both the BS in Physics and the BS in Biophysics are excellent preparations for elite graduate programs in the world. And so that's a little bit about the physics side of the degree. Now, how does all of this happen? It happens primarily through one-on-one mentoring. We are a teaching institution. We, as faculty members, are here to teach and mentor students. That is our job number one. It's more than our job, it's our life's calling. We take teaching and mentoring with utmost seriousness. We are not merely a large institution with a big brand name where you'll actually never get to spend time with the professor. Here in week one, all your professors are going to know you by name. You're going to be talking to professors one-on-one in their offices. You're going to be having coffee with them. You're going to be having lunch with them. You're going to be spending a lot of time with your professors because that's what we are here for. So here's who we are as faculty members of the department. So we have 6 faculty members in the department who are all permanent faculty members. We have Philip Mesor. He has a PhD in electrical engineering from the University of California, and he worked in the Silicon Valley in the semiconductor industry and had his own company, and also worked for a multi-billion-dollar company before he came here, has a lot of patents in the field of semiconductors, and he teaches our electrical engineering courses. Dr. David Schiff has a PhD in mechanical engineering from the University of Washington, and he worked for on submarines, on designing ways for submarines not to be detected by sonars. And David Schiff teaches a lot of courses in mechanical engineering. Dr. Richard Stevens has a PhD in physical chemistry, and he teaches a lot of our physics courses, and his specialty is optics and spectroscopy. You'll take a lot of courses in optics and optical related fields from Dr. Stevens. And my PhD is in aerospace engineering. My background is in designing advanced space propulsion systems, and for the last 27 years, I've done work with NASA on designing advanced space propulsion technologies. Dr. Marcus Ong has a PhD in materials engineering from Stanford University, and he has worked for many years on developing alternative energy hydrogen storage systems for the US government. And Dr. John Larkin also has a PhD in optics, and specifically in biomedical optics, using lasers to treat cancer and tumors. And so we have a faculty that is well-rounded in a variety of disciplines in engineering and physics. But what's important for you to realize is that we are here to teach and mentor students, because that's our primary purpose here. Now, what do our students do? We take teaching very seriously, but by teaching, we're not merely talking about teaching in the classroom. All our courses typically have a 3-hour lecture per week, 1 hour, 3 times a week, and then also a 3-hour lab per week, because we want our students to have both the theoretical and the hands-on aspects of learning. But in addition to the regular coursework of 3-hour lecture and 3-hour lab per week, we also have 4 design projects throughout the engineering curriculum, 1 in the freshman year, 1 in the sophomore/junior year, and 2 in the senior year. These are project-based courses where, especially in the senior design, you're actually going to be working with the external client from industry. You're designing an actual engineering project solution for a client in the industry. But in addition to those things as a part of the curriculum, we also have other projects for our students. Many of our students participate in the Near Space Research Project. What this is, the picture that you're seeing on the right is actually a picture that was taken by one of our freshman projects. Our students design and build and launch an experiment to go to the upper atmosphere to over 30,000 meters. To give you a context, your commercial jetliner flies at about 10,000 meters. This is more than 3 times the height of a commercial jetliner. So you take it to the very edge of the atmosphere, where you can see the blackness of space and the curvature of the Earth. And this is a project that is designed, built, and launched by first-year students. And they then, here we see some of our students collecting the experiments after they fell back to Earth on a parachute, and they analyze the data and the images to understand the upper atmosphere of the Earth. This is a first-year student project. But then we also have a multi-year student project that is it's a student-led mission to design, build, and launch and operate our own satellite. And we have student groups that are working on building the satellite structure, building a radiation detector to measure radiation in space, the electronics to control the radiation detector and the solar panel, and the telecommunication system. And then we also have a group that's working using the satellite to reach out to high schools to get students interested in engineering. So as you can see, we have lectures, we have labs, we have design projects as a part of the courses, and then we have other student research projects like this. So all of these things are a part of what we offer in the Department of Engineering and Physics. And with that, I'm going to stop my screen sharing and pass this back to Marie and Trina and see if Ishan wants to share anything.
Thank you, Dr. Sankaran. That, for me, is so incredibly informative and fascinating. So many takeaways, but what I really hear is that, yes, Whitworth prepares students for incredible futures at top universities and careers that are just out of this world. Couldn't resist. Ishan, I haven't met you yet. It's good to see you. It's good to meet you. Let's hear from you. So your experience as a student, some of the projects you worked on, and of course, we want to hear your title, where you're working now, and maybe how you got there. Thank you for joining us.
Yeah, can you guys hear me?
Yes.
Perfect. Hi, good morning, everybody. Yeah, so I joined Whitworth, oh boy, about 6 years and a couple months ago. Yeah, I joined in the computer science program, actually. And the first year I got there, I wanted to expand on like my technical field. So I wanted to get most of my technical subject matter out of the way. So I had computer science, math, physics, and then additional general education courses. There's one really incredible course that Whitworth provides. It's first year student engagement. So that's like a really good way for non-major specific faculty sometimes to get or for students to get used to the school culture, which I thought was really important. And I think most schools lack that Whitworth does really well. So yeah, I started out as a computer science student, and then by the end of my first year, I was like, wow, I kind of like physics more. So I jumped ship and I started looking into more physics. But again, at the end of the day, how Dr. K mentioned, it's all very interdisciplinary. A lot of the work that I did in physics involved some form of coding. So I was a part of the NearSpace project, which, as you could tell, was super fun. I got to launch stuff up in space that I would have never gotten to, or probably will never get to. That was a very, very great experience. I don't know if, later down the line, it's one of those things that you're not ever going to have a chance to do, and Whitworth provides, which is really astounding. And as an employee at Boeing, it's astounding how you can send something that high, the amount of work that needs to be done to send something that high, notify all sorts of regulatory agency. And I really appreciate Dr. John Larkin when I took the course for doing all of that. So second year, I graduated towards more physics, more engineering. I didn't really necessarily know what I wanted to do by my second year, and that was completely okay, because the program is so that you get to dabble in a lot of these physics-based courses. So as I was taking NearSpace, I was taking other courses in statics, dynamics, mechanics, and all sorts of facets of engineering where I could explore what did I like most. And then right around the time, towards the end of the second year, I think I decided that the 3-2 program, the partnership program, would be good for me because it would extend my time in school, give me an extra degree, and also some time to think about what I wanted to do. And then my third year, I got involved with research with Dr. Meeser, actually, in the field of optics, which, again, if you had asked me the first day or the first time I got to Whitworth if I ever wanted to do optics, the answer would have been no. But I really appreciate Whitworth giving me the opportunity to expand on all those different facets. So I was working on research in optics. And then I think right around that time, I knew I wanted to be in the electrical domain. not necessarily sure what. So all this Boeing thing didn't happen until I got to my partner school. Then I realized, wow, electrical engineering is not just wires and electrons and electrodynamics. There's a lot more to electrical engineering. There's the neuroscience aspect to electrical engineering, which is, kind of astounding, because we can take principles from neuroscience, from electrical engineering to neuroscience. So I got involved in that faucet, and then I started working and really exploring linear dynamical systems, which is like a very particular facet of mathematics. And again, as you can hear, I'm like jumping from different fields. So it's very interconnected, interdisciplinary work. So from there, yeah, I started getting more into mathematics, more into these dynamical systems, non-linear dynamical systems, and how they interact with their environment, how to make things safer, more efficient, from more of like a mathematical background rather than like an or environmental aspect. And right around the end of my 5th year in college, I decided to tack on one more year just to get that master's as well. And by that time, I knew I wanted to do something in like linear dynamical systems and controls regime. And then I ended up at Boeing as a controls engineer.
So Ishan, and by the way, it's great to see you again.
Yes, you too.
Yeah, could you explain a little bit more about your role at Boeing? And, there's guidance, navigation, and control. So are you working with the guidance systems in planes, or, is there more to it than that?
Yeah, that's a great question. I get this question a lot. So what exactly is guidance, navigation, and control? And as you can, I mean, it's very difficult to explain like when I tried to explain it, I did a terrible job, but then my manager was like, okay, this is how you explain it. And I really liked his explanation. So basically guidance is where you want to, so guidance is how you want to get there. So you're on a plane, you're in some space somewhere, and where you want to go is guidance. Navigation is knowing where you are, because that in itself is a very difficult problem. Knowing exactly where you are, what your airspeed is, and everything. So that's navigation. And control is how you get there. So how quickly do you want to get there? If you want to save time, do you want to save energy? How do you want to do it? Do you want to make it like a roller coaster ride, or do you want to make it very tame and comfortable? And again, if you like, as you can imagine, small planes and big planes have rather drastic functionality. So control is how you want to get there, and the study of that. So as a guidance, navigation, and controls engineer, my particular expertise is in the control side, more so like I guess like the fun side. I'm a little biased. How you want to get there and all the fun stuff along that. So so currently at Boeing, I work in the PD team, so we call product development. So I necessarily don't have a plane. So this is a hoax. I don't work on the 747. I mean, nobody works on the 747. The program's about to get, I mean, it's done and the final plane is out currently. So I work in the product development team, which is this very interdisciplinary team where we're looking into revolutionizing the flight deck. So we want to improve on our existing technologies, maybe bring on some new, maybe beat the competition currently. So all these different kinds of engineering mixed together in this very interdisciplinary team, we tackle on problems. Again, a lot of these things I can't necessarily say. But we are looking into maybe redesigning some of our control laws, just speaking in like very high level, maybe making the plane more efficient, maybe making it feel slightly differently, or making it easier for the customer, which in our case are pilots, making their life easy by maybe expanding auto flight or stuff like that. So we work, I primarily work with a lot of aerospace engineers And even though I'm an electrical engineer with controls background, I work with aerospace engineers. I work with more mechanical electrical people who are looking into pilot controls. And yeah, it's a very interesting dynamic in like the work environment. And also, like, when I think about it, I think I was like really well prepared for this very technically different. So each individual with technically different technical backgrounds and how to communicate with that. And I think I started learning that from Whitworth, because even though I wanted to be an electrical engineer, I had friends who were in like biology who wanted to do biophysics, and like how you communicate with them is rather different. The language you use is rather different. And I think I really appreciated that facet as well, of being able to work with very different technically gifted folks from like a really early on career, at least in my higher education career. So that's kind of like what I do. I do controls. Right now, it's only been 5 months, so I'm not getting any of like the fun, juicy projects, but hopefully.
Thank you, Ishan. What do you think, Trina? Should we open it up to questions?
Let's do it.
Yeah, I see that we have someone who has raised their hand. And we can allow them to talk if they're interested, or let's include that functionality. Falabomi, would you like to speak with us, or would you be more comfortable putting your question in the chat box? Okay, well, maybe we will go see if we have a question in the chat box. Maybe they're more comfortable with that. We don't seem to have any open questions, however. So maybe the question that student had has been answered. So Trina, do you have any questions for Kamesh or Ishan while people think about their questions?
Yes, actually, and please, those of you who are listening and attending, don't be shy. That's what we're here for, the chat box, or, you know, we can try to let you in. Folamboni, I did click on a button that would allow you to unmute yourself if you want to still jump in. In the meantime, Marie and I, of course, speak with a lot of students considering the programs. And there are some students out there, which you both, Ishan and Dr. K, I learned something new today. I can call you Dr. K. Both of you touched on this a little bit, but could you elaborate a little bit on what if a student is interested in engineering, but not really sure if they have the smarts or the background, or they just don't know how to begin? Is it okay to start in the program and take a few classes? Will they feel over their head? Will it, you know, will they crash and burn, or is there the support system in there for the check it out, the look-see?
Well, Trina, that's a very important question, because the experience that Ishan shared is far more common than people realize, because the nature of the college process is that we are asking someone to make a big life decision when they're 17 or 18.
So true.
How much do we really, speaking as adults who have, for whom that age was many years in the rearview mirror, how well do we really know ourselves when we are 17 or 18? We don't know ourselves well at that stage of life. And you don't know what each of these disciplines was. Like I said, I went into aerospace engineering because it had the word space in it, and I thought that sounded cool. And that was the extent of what I knew about aerospace engineering. And so how well can we expect a 17 or 18-year-old to really know what a fill-in-the-blank discipline is? So given all of those unknowns, it's entirely reasonable to expect that there will be a lot of changes. You learn more about yourself, you learn more about the field. And the way Whitworth is structured is that we not just allow, we actually invite a student to explore these different things because it's a part of their growth. Their growth is not merely the technical learning, it's also learning about themselves. So Ishan shared about how he began in computer science, and then he liked physics, and then he liked engineering, and then he was doing optics, and then he ended up doing electrical engineering. Now he's working on airplanes, right? And that is very appropriate because that is revealing growth. And growth is what we want to see in college students. And so that's why Whitworth is a place that welcomes that type of an exploration. And the way it happens is that we don't just leave a student out on their own, okay, go figure this thing out. Ishan mentioned this first year seminar that we have for incoming students, where you have a professor who walks with you first on the basics of how to navigate life in college. And especially for international students, I remember back in the day when I was an international student from India, and I was landed in Chicago, and I didn't know what was what. I didn't know anything about registering for classes. I didn't know this thing about why were all of these gaps in my schedule and all of those things, and how to navigate financial aid, how to find an on-campus job. All of those things were completely new to me. And at Whitworth, we have an experienced faculty member who's a student's guide through all of that, so that you're not just, it's not a sink or swim. You have a guide who's there to navigate those things with you. And then when it comes to academic discernment, you know, do I like computer science? Do I like physics? Do I like engineering? A student doesn't have to figure this out on one's own. You can talk to this advisor, you can talk to the professors to say, hey, I'm liking this, I'm not liking this, what do I do with this? All of those conversations are very much a part of how we help a student grow, both as a person and as a scientist and engineer.
And Kamesh, you also really point to one of the real strengths of the US education program, because as you know, in many countries, many education systems, students are funneled into a specific major based on exam scores, whether they want to be in that major or not, whether they end up loving or hating that major, they are stuck with it, and they are stuck with that career path. And even in some US universities, students are admitted directly into a major, and changing their major if they discover they don't like it but would prefer another major is difficult or impossible as well. But this whole notion of exploration and growth and development is foundational to Whitworth University and its interdisciplinary liberal arts and sciences program. So it was a perfect choice for a student like Ishan, who developed his knowledge, his skills, his interests, and figured out his path, because we as an institution gave him the space and opportunity to do that. And you as a faculty member and your colleagues gave him the support.
Marie, wholeheartedly affirm that, and I'm sure Ishan can share that from his experience as well. Where I grew up in India, there was very much this educational system of funneling people into specific majors based on test scores. And I'm so grateful that when I came to the US, I had a little more of an option to explore. But as Marie pointed out, many universities, even in the US, make people choose their major very early on. So, Murray, to your point, I went to an all science and engineering school. I was a fill in the blank Institute of Technology. I don't want to give away any more than that. And there, students had to pick their specific subspecialty in engineering upon entry as freshmen. And how much does, and I was 17 when I started my freshman year, how much did I really know what I was signing up for? It's a strength of the Whitworth system that it allows for some of those exploration based on personal growth as well as professional discernment.
This is so fascinating, and I just love to hear about how Whitworth is just the vessel of support, along with just that the ability to allow students to explore and dive deep in their intellect and, you know, follow their strengths and put away their weaknesses or use their weaknesses in another way. Let's, as we close, as we move toward closing, I know there's no questions, which is great because that means that we're covering a lot of bases. Ishan, would you lead us out in addressing, you know, from your perspective, what would you tell new incoming students who are interested in engineering or physics about, this is a big ask, this is a big question, about Whitworth, about the program? You know, what would be your piece of advice for those students who used to be you before you arrived?
Yeah, I think that, yeah, your former question also kind of, I want to touch on that as well a little bit.
Sure.
Yeah, I mean, I think one big piece of advice would be, again, be as curious as possible. I know I'm just going to say the most cookie cutter answer possible because it worked for me. I mean, there's a reason why people preach it. So be as curious as possible. And there are going to be classes that you will think that you won't be able to succeed in. And that's completely fine. I mean, 1B didn't hurt anybody. Like, none of us are straight A students. None of us should ever strive to be straight A students. I firmly believe that, because it's important to really enjoy your collegiate life, because you only get it once. Again, cookie cutter answers right here. But I think staying curious academically, socially, emotionally is very important in college. And not being afraid to like take a difficult class and then midway through realize, oh, wow, I really enjoy this. I'm glad I took it. That is an excellent outcome. Or maybe it's like, oh, wow, I really don't like this. Maybe I don't like it because it's too difficult. Maybe I don't like it because I don't have the proper like support. And those are completely valid reasons. And being like, okay, maybe this isn't for me, which is also a very good outcome because you've learned something about yourself. And also just asking questions, because if you're struggling with classes, if you're struggling with something, especially at Whitworth, you have the ability to knock on your professor's door, which is absolutely crazy. It is not possible to knock on your professor's door in any other colleges. It is astounding to me how available our professors are. Even at WashU, when I transferred into WashU, I rarely met my professors, and because they were busy, because they had research, they had other things on their table, but it was still very difficult to get a hold of them. But at Whitworth, we have professors to knock on for technical questions, guidance, mentorship, all these different kind of things that you would have specialized departments for in other schools. So career development would be a place you would go for career advice, but I could have just knocked on Dr. K's door and be like, hey, Dr. K, I don't know what to do. So I think being curious, asking a lot of questions, and then just trying to be like your genuine self in college is extremely important. Because again, like snap and 6 years are gone. I mean, if you end up in a PhD program, 7, 8 year, 10 years are gone without you even realizing how quickly time passes. So I think it's very important to stay curious, asking the right questions, and then just enjoying life. I know these are like super cookie cutter answers, but they've worked for me. They've worked for a lot of my friends. They've worked for a lot of other peers. So I really want to hone in on that for closing.
Great answer, Ishan. Not that cookie cutter, really. And, you know, I would also just like to mention that that mentorship piece, that faculty mentorship piece that Ishan referred to, it is very real. You know, we have students in our offices all the time, Trina and I, because we're, you know, we're also advisors to the international students. And so often they talk about their professors and, you know, how helpful they are. And as for Professor Sankaran, in the years that I've been at Whitworth, I would say 80–90% of the time that I have, you know, gone to lunch in our dining hall, he is there eating lunch with a student. It's really pretty awesome, but you know, he's not the only one either. You know, professors and students really do get to know one another, and there really is that personalized support, which obviously has worked out very well for our alumni, as you can see with Ishan Gowley. I'm so glad that you found your path and are working on things that you have not only trained for, but love to do.
Yes. Yeah, there was a question on chat. I just want to address it really quickly. Yes, that's a
Thank
great
you.
question.
Thank you.
Yes, you can explore multiple majors. There are interdisciplinary science requirements. So as a physics student, you have to take a few chemistry classes. And a really nice thing about our department is if we offer a very similar course, we will count the courses. So if you can take maybe physical chemistry, I'm not exactly sure what course this is, and Dr. K can touch on it, but you can take a lab in the chemistry department and take the course in the physics department, and both those count towards your major. So there are classes where you can double dip. With biophysics and computer science, yes, there are bioinformatics courses that double dip. So yes, that's a very good question. And yes, you can do both, even at like a senior to a junior level.
Correct. Thank you for addressing that, Ishan. He is absolutely right. We are very much a tightly integrated university. There are other universities that are where departments function in silos. Courses you take here will only count in this department. Courses here will only in this department. In fact, at Whitworth, it's very common for students to get 2 majors in their normal course of a 4-year degree. And the way 2 majors work is that a lot of the classes at Whitworth are what are considered shared curriculum classes. They'll count towards, no matter what major you're in, they'll count towards that. And then specifically between departments, as Ishan pointed out, there are classes that we share across departments. So for instance, Ishan mentioned thermochemistry will count towards both the physics side and the chemistry side. Thermal physics will count in the physics side as well as in the chemistry side. In a similar way, in math, and so I teach an engineering mathematics class that counts both for the engineering side and the physics side, and as well as the math department. So there are courses that count for multiple departments. And then we also have these interdisciplinary majors that bring in expertise from multiple departments. Biophysics by itself is one that brings in expertise from physics and biology. And the bioinformatics that Ishan mentioned brings in that with the computer science aspect of it. If you think about sequencing a genome, it's a computationally intensive problem. So how do you understand things such as genome sequencing, protein folding to come up with designer drugs for us to attack a specific pathogen? Those types of things are computationally intensive problems. So we have these majors that bring in expertise from computer science, from physics, from math and biology. All of those things are very much a part of our interdisciplinary way we do education at Whitworth.
Excellent. That was a great way to wrap up. I think Dr. K, you have a class to teach soon. And Ishan, thank you for joining us from your work day, your morning work day.
Yes.
One thing I would like to say as we close and thank our team here is that the Whitworth website, you may already know this, but if you're interested in asking questions to the professors like Dr. K, if you go to the particular website, you could scroll down to the bottom of the page of, for example, engineering or physics, and you'll see a little summary snapshot of each professor, which will also allow you to reach out by email and ask them questions. And I know from hearing Dr. K talk that they are very happy to hear from you and to answer your questions. Yes, they're busy. It might not be right away, but that's what they're there for, is to engage with you as a student who is considering Whitworth, the commitment for your education. So please don't hesitate. Would you like to just say one more thing in parting, or are we good? Marie, any final thoughts? Dr. K?
I would just say, if you have general admissions questions, also as an international student, don't hesitate to reach out to Trina and me. Our emails are on the website, our individual emails. We also have the WU Intel admissions general email. Basically, if you have questions, we're all happy to answer them.
Thank you for joining us. Thank you both. It was a
Thank
wonderful presentation, and we'll see you soon. Take care, everyone. Thank you.
Thank you.